Hi everyone, I am Emanuele Goes, a PhD student at the University of Alberta, and today I will present a study evaluating the Chitosan oligosaccharides as potential antibiotic replacements in broiler diets. The large use of antibiotics as growth promoters in animal diets increases the risk of resistant pathogenic bacteria and the risk of cross-resistance in humans through the meat consumption. And all these potential risks motivated the consumer to demand antibiotic-free products. This pressure from consumers has caused the industry to adapt to new standards, reducing or eliminating the use of antibiotics as growth promoters in animal diets. However, the reduction in the use of antibiotics as growth promoters in broiler diets has been increasing the flock's susceptibility to enteric diseases, such as the necrotic enteritis, an enteric disease caused by the pathogen Clostridium perfringens that is not a new concern in the poultry industry. However, it has been intensified with the antibiotics withdrawal. And as a result, we have a decrease in broilers' performance, which is causing economic losses for producers and also for the industry. A way to minimize these problems would be to find effective antibiotic replacements able to keep the animal health, performance, and also allow us to produce a safe protein source for human consumption. In this way, the additive we are studying as potential AGP replacer are the chitosan oligosaccharides. The process to obtain the chitosan starts with the chitin extraction from shellfish that came from crustacean waste. Then, after undergoing some enzymatic and chemical processes, we can obtain the chitosan oligosaccharides. Research shows that chitosan oligosaccharides can have antimicrobial properties. Since it's the only natural positively charged polysaccharide, they can interact with anionic groups on microbial cell membranes, causing the leakage of the intracellular content and then preventing the proliferation of pathogenic bacteria. They can also have anti-inflammatory properties. Since the amino groups present in this compound can be recognized by the immune system, they can induce the humoral and cell-mediated immune responses. And they can also act as a prebiotic, bringing benefits for the commensal bacteria and by competitive exclusion, preventing the proliferation of pathogenic bacteria. The chitosan action will depend on its molecular weight and the acetylation degree, being the compounds with low molecular weight responsible for antimicrobial responses, the medium molecular weight responsible for boost the immune system, and the low molecular weight can act as a prebiotic. Thus, our objective with this study was to evaluate the dietary shellfish chitosan oligosaccharides as potential antibiotic growth promoter replacements on performance, necrotic enteritis lesion scores in the jejunum, and carcass traits of broilers from 0 to 38 days of age. To achieve our objectives, we used a total of 1,152 broilers, and the birds were randomly distributed in 8 treatments of 8 replicates of 18 birds each, and the experimental treatments were a positive control diet, that was a commercial type diet, plus antibiotic and plus coccidiostat, a negative control diet, that was a commercial type diet without any medications, and 3 different chitosan products included in different levels. So we had chitosan 95 kDa, that is the molecular weight, included at 0.2 and 5 grams per kilo of the diet. We also had chitosan 110 kDa, included at 5 grams per kilo of the diet. And we had chitosan 180 kDa, included at 0.2, 2 and 5 grams per kilo of the diet. So the products and the levels of inclusion that were selected, they were selected based on a previous pilot project. We applied a subclinical necrotic enteritis challenge in all birds, and for that, at 12 days of age, we applied 15 times the recommended doses of coccidiosis vaccine by gavage, plus 24-hour feed removal at 18 days of age. The main purpose of this challenge was to cause a mild disruption in the intestinal barrier and stimulate the proliferation of the Clostridium perfringens. Then, we also evaluate the performance, and for that, we evaluate performance at the end of the starter, grower, and finisher phases, and also during the whole period, from 0 to 36 days of age. At 22 and 38 days of age, 2 birds per replicate were euthanized by cervical delocation, and then the necrotic enteritis lesion scores were evaluated in the jejunum. The scores were from 0 to 4, where 0 was given for healthy tissues and increasing according to the severity of the lesions until score 4. Then, at 38 days of age, we evaluate the carcass traits, and for that, we measure the whole chilled carcass weight and also the percentage of P major, P minor, drumsticks, thighs, and wings. And what were the results we found? So here we have the growth performance results during the starter and grower phases. That was before and after the challenge. Before the challenge, we found a significant difference for body weight at 10 days of age and body weight gain per day per bird. The positive control treatment was responsible for the lower body weight and body weight gain in comparison with all other treatments, and there was no significant difference for feed intake or for feed conversion ratio in this phase. Then, after the challenge, we did not find a difference between the positive control and negative control treatments, making it difficult to test the efficacy of the Chitosan products to support the challenge applied. However, we found a significant difference for body weight at 25 days of age, being the Chitosan 95 kDa included at 5 grams per kilo superior to the Chitosan 180 kDa included at 5 grams per kilo of the diet. Then, for body weight gain per day per bird, the positive control was superior to the Chitosan 180 kDa included at 5 grams per kilo. And then, for feed conversion ratio was the same. The positive control treatment was superior to the Chitosan 180 kDa included at 5 grams per kilo, but similar to the other treatments, inclusive the negative control group. Here we have the performance results for the whole period, from 0 to 36 days of age. And we can see that once again, we could not find difference between the positive control and negative control groups. Moreover, we did not find significant difference for any of the evaluated parameters. However, the body weight per bird at 36 days of age had a tendency to be significant, being the Chitosan 95 kDa included at 5 grams per kilo, responsible for heavier birds. Birds from this treatment were 45.5 grams heavier than birds from the positive control group and 81.6 grams heavier than those from the negative control group. Here we have the necrotic enteritis lesion scores evaluated in the jejunum at 20 and 38 days of age. Since the data does not have a normal distribution, we used a non-parametric test to evaluate the data. And this way, we transformed score and mean rankings, where higher values represent the higher frequency of more severe lesions. And here we can observe that we had no difference between the positive control and the negative control group. And also, we did not have any significant difference among of the other treatments as well. Here we have the results for the carcass traits evaluated at 38 days of age. And once again, we did not find significant difference between the positive control and negative control group for any of the carcass parameters evaluated. In addition, the only significant difference found was for the percentage of drumsticks, where birds from the negative control treatment had a higher percentage of drumsticks than birds from the Chitosan 110 kDa group, and there was no significant difference among treatments for any other evaluated parameter. In summary, as you saw in the results, the lack of difference between our positive control and negative control treatment made it difficult to assess the effectiveness of the experimental treatments. So, based on our results at this point, we cannot say that chitosan can replace antibiotics. And also, we may need to make adjustments in our challenge model to try to find a difference between the positive control and the negative control treatments, and then be able to effectively evaluate the chitosan product's response. Although we could not find a difference between the positive control and negative control treatments, the chitosan 95 kDa, mainly the one included at 5 grams per kilo of the diet, showed some promise to replace or to be a part of a strategy to replace antibiotics. However, complementary analyses are still needed. In the case of this current study, we still have to analyze the intestinal content microbiome and the serum presence of antibody and cytokines. Based on these results, we hope to have a more precise conclusion. But we still believe that further studies are necessary to test an adjusted challenge model and effectively test the potential of chitosan to replace antibiotics, and then understand the mechanism of action involved. I would like to thank our partners and the sponsors of this project for all the help and support they have given us. Thank you so much for your time and attention, and I look forward to answer any questions you may have. See you and have a great day.
Thank you, Mrs. Goes, for your presentation. We have a question from, well, I was about to say from the floor, but from the internet, from the attendants. And it's regarding your subclinical necrotic enteritis challenge. As you have so question is the validity of the model to demonstrate the difference between your treatments. So you never used necrotic Clostridium perfringens. You only used 15 times the vaccine.
Yes, we only use it 15 times the recommended doses of coccidiosis vaccine, once at 12 days of age in all birds. But we did other trials as well, evaluating some other additives to replace antibiotics, and we found the same. We could not find significant difference between our positive and negative control treatments. So we are working on our challenge model. Since we want to cause subclinical necrotic enteritis, it's hard to find ideal model because we don't want to see clinical signs of necrotic enteritis. We just want to decrease the performance of the animals and not see any mortalities or other clinical signs. So right now we are working in partnership with some others immunologists here in U of A and in UK as well, to trying to find another to adjust our challenge model and then maybe redo this last trial or select some of the treatments to test the challenge model again. But we still believe that we have to work on our challenge model, maybe using strains of Clostridium perfringens or using more than once, applying more than once the coccidiosis vaccine.
Okay, well, it then may be more recommended suggestion from the attendees the attendee who was suggesting that perhaps using the term necrotic enteritis challenge as a model in this situation is probably not the best appropriate terminology, since there's no Clostridium perfringens inoculation.
Yeah.
I guess it's always is a challenge trying to find I would say it is a challenge for the researcher to find a model that will allow you to basically recreate some dysbiosis or some intestinal problems without affecting creating mortality and
like to keep the welfare in general, but create a challenge to reduce performance. Yeah, but we hope we hope with the help with these partners to select some another challenge and test it soon, because we have other trials involving additives to replace antibiotics to test soon. So our priority now is working on the challenge model.